Good day, everyone. Our topic is statistical inference of two sample. This lesson focuses on how we can compare two different groups or populations to determine if their means are significantly different. For example, if we want to know whether two classes of students have different average scores, or if two machines produce items with different average weights, we use this statistical method. Next slide. Inference on the difference in means of two normal distribution. The test of difference of means is used to find out whether there's a significant difference between two populations that have the same type of characteristics. In simpler terms, trying to see if two groups are really different or if any observed difference just happened by chance. For example, let's say we want to know if there is a significant difference between the performance of two classes of engineering students enrolled in statistics. If both classes took the same exam, we can use this test to compare their mean scores and see if one class performed better. Next slide. Inference and difference in means. Hypothesis testing. When we conduct this test, we start by stating our hypothesis. The null hypothesis written as means there is no significant difference between the two population means. The alternative hypothesis written as means there is a significant difference. If we want to test if one mean is greater or less than other, it becomes simple. Hypothesis 1 means population 1 has a higher mean than population 2. Hypothesis 2 means population 1 has a lower mean than population 2. Next slide. Z-test formula for two means. When we deal with large samples, meaning each sample has at least 30 data points, and the population variance are known, we use the test Z-test. The formula is yan po, nasa screen man po natin yung formula po ng Z-test po natin. This Z-value help us determine how far the samples are apart relative to the variability of the data. Then, we compare the computed Z-value with a critical Z-value from the Z-table to decide whether to reject or accept the null hypothesis. Next, sample 1. Two large independent classes took the same standard test. Class A sample mean score is 78 with population variance of 144 and sample size of 64. Class B sample mean is 74 with population variance of 100 and sample size 1% significant level test whether Class A performs better than Class B, 110. Lalagay po lang natin yung mga given po natin. Tapos, ilalagay lang po natin yung mga given natin dun po sa formula natin para makuha po natin yung Z value tapos yung 110 P value din po. Tapos pwede na po tayong makapag-create ng conclusion.
So for the next topic, it is all about the inference on the difference in means of two normal distributions with variance known. The test of difference of means is used to determine if there is significant difference between two populations of the same characteristics. For example, it is used to know if there is significant difference between the performance of two classes of engineering students enrolled in statistics. Next slide, please. Sample problem number 1. A company wants to see if their so-called ergonomic new keyboard reduces hand strain. They tested 50 people using a regular keyboard and 45 people using the new keyboard. The average fatigue scores were 6.2 for the regular keyboard and 5.7 for the new one. If A equals 0.05, determine through testing if the new keyboard actually lowers fatigue. So the problem says that the study aims to determine if the new ergonomic keyboard actually helps reduce hand fatigue. So the first step is we test at 5% level of significance, then we set their hypothesis. For the null hypothesis, the new keyboard does not reduce fatigue. Then the alternative hypothesis, the new keyboard reduces fatigue. So we compute using the test statistic using z-value. So we use two sample z-test for comparing means since both sample sizes are large. So substituting the values, z equals 5.7 minus 6.2 all over the square root of 1.0 squared over 45 plus 1.1 squared all over 50. So the result is negative 2.321. Then decision rule and p-value. The one-tailed p-value is equal to 0.01015. So since p is less than 0.05, we reject the null hypothesis. So the conclusion is at 5% level of significance, there is enough statistical evidence to conclude that the new keyboard significantly reduces typing fatigue compared to the regular keyboard. Next slide, please. So the next problem is all about a nutritionist wanted to check which soup brand has higher sodium content. Brand A has an average sodium level of 540 milligrams, while brand B has 525 milligrams. So here we are testing this using a 1% level of significance. So we set the hypothesis. So for the null hypothesis, both brands have the same mean sodium content, while alternative hypothesis, brand A has higher sodium content than brand B. So we use z-test calculation, then z equals 540 minus 525 all over square root of 25 squared over 40 plus 20 squared all over 35. So the answer is 2.884. So since p is less than 0.01, we reject the null hypothesis. So the conclusion for this sample problem is there is strong evidence that brand A has higher mean sodium content than brand B at the 1% significance level. Next slide, please. For the last sample problem, we are testing whether two coffee packing machines fill the same amount of coffee on average. Machine 1 averages 50.2 grams and machine 2 averages 49.9 grams with the standard deviations of 0.8 and 0.7 respectively. So first we set the hypothesis. So for null hypothesis, both machines fill the same average amount, while alternative hypothesis, there is significant difference in the average amount filled. So we z-test calculation. Z equals 50.2 minus 49.9 all over the square root of 0.8 squared over 70 plus 0.7 squared over 65. So the value that we will get is 2.884. So since P is less than 0.005, we reject the null hypothesis. So the conclusion would be there is significant difference in the average amount filled by the two machines. Next slide, please.
So
So dito naman tayo sa interference of difference in means. Variance unknown naman. This test compares two samples means from normal population where the variances are unknown. It's mainly used for small samples like n less than 30. As we have two cases. One is if variances are equal, we use a pooled t-test. Then pagka hindi naman not equal, we use a separate variance t-test. So we got our formula here. T equals to mean sub 1 equals mean sub 2 minus hypothesis all over standard deviation multiplied by square root of 1 over n sub 1 plus 1 over n sub 2. Then sa pooled variance naman is ayun lang, standard deviation na naka-squared na n sub 1, yun. Tas next slide please. Dito naman tayo sa pangalawang case, yung hindi equal. Separate variance t-test, unequal variances. We got our formula. Ganun lang din yung sa t-test natin. Pinagkaiba lang is yung standard deviation natin is numerator na siya. Hindi na siya nakamultiply. Then sa degrees of freedom naman is ganun. Medyo mahaba tsaka nakakalito. So dapat sa ulo. So yan. Next slide please. Problem naman. We got our problem here. Where problem 1, we're comparing the mean strength of total metal rods type A and type B. So our table here states that type A natin is yung sample size natin is 5.8, then mean 52, standard deviation is 4, while sa type B, sample size natin is 10, then mean 49, standard deviation natin is 3. Then we will test if type A is stronger at 5% significant level. So solution natin, set our hypothesis. Yan, mean A equals to mean B. Then hypothesis 1 natin is mean A greater than mean B ba yan? Tama. Then ano ba to? Yung mabasa. Compute natin yung pooled variance. Yan. Ganun lang din siya. Isa-substitute mo lang din sa formula natin kanina, yung medyo magulo. Then, ang makukuha nating value doon is 12.06. So, ano pa yun? Standard deviation na naka-squared. Square root pa natin yun para makuha natin yung standard deviation lang na hindi naka-squared. So, ang magiging value doon is 3.47. Yan. Then, compute natin yung test statistic. Ganun lang ulit. Substitute natin yung mga values natin dun sa formula natin. Salpak lang, ganun lang. Ilalagay lang sa calculator. Then, ang makukuha nating value doon is 1.82. Then, doon naman sa degrees of freedom, ganun lang. Same lang as is na sasalpak mo lang sa calculator. Then, ang makukuha natin is 16. Then, critical value, yan, 1.746. Ano yan? Yung gagawin mo dyan is yung degrees of freedom mo, imumultiply mo dun sa level of significance natin. So, ang makukuha natin is 1.746. So, therefore, meron na tayo ng sagot. Conclusion natin is 1.82 greater than 1.746. So, we reject the hypothesis, yung pinakaunang hypothesis. So, ang sagot natin is type A rods are significantly stronger than type B rods. So yun, next slide please. Yan. A nutritionist wants to know if brand X has higher average protein content than brand Y. So, got table ulit. Yung given natin yan, hindi ko na ulit babasahin. We will test na yun, we will set our hypothesis ulit. Hypothesis 1 ay sub 0 equals mean 1 equals mean B. Then ayun lang ulit, ganun lang ulit, pooled variance ulit, substitute back sa formula natin. Pag ang makukuha natin doon is 5.24, yung naka-squared pa. Tapos i-square root ulit natin para makuha yung standard deviation na which is 2.29. Then we will compute ulit yung compute test statistic, substitute back our values sa formula ulit. We will get the value of 2.03. Then, ganun ulit, degrees of freedom. DF, denoted siya ng DF. So, ang makukuha natin dun is 20. Yes, 20. Then, sa critical values naman, critical values, i-multiply ulit yung level of significance sa nakuha nating degrees of freedom, which is ang nakuha natin sa problem natin is 1.725. So, therefore, ang conclusion natin is 2.03 greater than 1.725. So, we reject yung pinakauna nating hypothesis. So, overall, brand X has significantly higher protein content than brand Y. So, yun. And done.
So for next sample problem, an engineer wants to compare the average lifetimes of two brands of LED bulbs, brand A and brand B. Previous data suggests the lifetimes are normally distributed, but the variances are not equal. Two random samples are collected. At the 0.01 level of significance, is there evidence that the mean lifetime of brand A bulbs differs from that of brand B bulbs? So our given, for brand A, our sample size is 10, our mean is 1,320, and our standard deviation is 120. While for brand A, our sample size is 12, our mean is 1,250, and our standard deviation is 80. So firstly, we will form our hypothesis. So our null hypothesis is mu sub 1 is equal to mu sub 2, which means that there's no difference between the mean lifetime of brand A and brand B. While our alternative hypothesis is mu sub 1 is unequal to mu sub 2. Our significance level is alpha equals 0.01, and it is two-tailed. So why is it two-tailed? It is two-tailed because, just like asked in the problem, is there evidence that the mean lifetime of brand A bulbs differs? So our keyword is differs. So it could be greater than or less than. That's why it's two-tailed. And we will use the inequality sign for the alternative hypothesis. So now we will solve for the standard error using unequal variance. So SE is equal to the square root of the quantity S sub 1 squared over N sub 1 plus the quantity S sub 2 squared over N sub 2. After plugging in the values, we have the square root of 120 squared over 15 plus 80 squared over 12. 120 squared is 14,400 and 80 squared is 6,400. So we have the square root of 960 plus 533.33. and that is 38.64. So now we have the standard error. We can now compute for the t-statistic. The t-statistic is just the mean of brand A minus the mean of brand B over our computed standard error. That's 1,320 minus 12,050 over 38.64. So that's 70 over 38.64, which is equal to 1.81. And next we have the degrees of freedom, which we will solve using the Welch's formula. df is equal to the quantity s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2 squared divided by s sub 1 squared over n sub 1 squared over the quantity n sub 1 minus 1 plus the quantity s sub 2 squared over n sub 2 squared over the quantity n sub 2 minus 1. So ipa-plug in natin yung values. We have 960 plus 533.33 squared divided by the quantity 960 squared over 14 plus the quantity 533.33 squared over 11. So after that, we will end up with a DF of 24.3 or approximately 24. So meron na tayong DF. We can now find the critical value. So ang gagamitin natin na level of significance sa critical value is always 0.05. So after using 0.05 and 24, we will have a critical value of 2.797. And since yung nahanap natin earlier na t-statistic 1.81 ay mas maliit sa ating critical value, our decision is to not reject the null hypothesis. So ang conclusion, there is no evidence that the mean lifetime of brand A bulbs differs from that of brand B bulbs. Next slide, please. So now we will compute for t-statistic. So our t sub c is equal to the mean of the first sample minus the mean of the second sample minus d sub 0 over s sub p times the square root of 1 over n sub 1, yung sample size nung first sample, plus 1 over the sample size of the second sample. So after plugging in the values, we have 85 minus 81 minus 2 over 4.478 times the square root of 1 over 12 plus 1 over 10. We have a t sub c of 1.04. So how do we find the s sub p? So the formula for s sub p, we have two formulas. Yung isa may exponent tayo, s sub p squared. Yung isa na-cancel na yung exponent, and nasa loob ng radical yung other side ng equation. So gamitin natin formula is yung na-cancel na yung exponent ng s sub p. So we will just plug in the values to solve for s sub p. So we have the sample size of the first sample, which is 12 subtracted by 1, so that's 11, times the standard deviation of the first sample, 4 squared, so that's 16. So we have 11 times 16 plus, ulitin lang natin yung process sa second sample, and we have 9 times 25. Then we will divide that with n sub 1 plus n sub 2 minus 2. So that's 12 plus 10 minus 2. Magiging sagot nun, hahanapin lang natin yung square root, and that's our s sub p, 4.478. So ang ating decision and interpretation, firstly, we will not reject the null hypothesis since our T sub C 1.04 is less than the critical value 1.725. Therefore, we are unable to agree that the hardness of material A exceeds that of material B by more than 2 units at 5% level of significance. Using the p-value approach, the p-value corresponding to T equals 1.04 is 0.16, which is higher than 0.05. So even if we use the p-value approach, we will still reject the null hypothesis. Next, inference on the variance of two normal distributions. The problem involves testing the equality of the variances sigma sub 1 squared and sigma sub 2 squared of two populations. The null hypothesis is H sub 0 is sigma sub 1 squared equals sigma sub 2 squared. So, iba siya dun sa ating null hypothesis previously, since instead of the mean of the population, we are testing the difference of the standard deviation of the population. This is tested against one of the usual alternatives. Next slide, please. Example, the BSU Alangilan Billiards coach wants to know whether players trained with the new practice drill have a higher average game score than players using the traditional drill. Two independent random samples were taken. The given is n sub 1 equals 12, x sub 1 equals 82, s sub 1 equals 5 for the new drill, n sub 2 equals 10, x sub 2 equals 78, s sub 2 equals 6 for traditional. Our significance level is alpha equals 0.05. So, ano bang gagamitin natin? One-tailed or two-tailed? If we analyze the question again, it says here that the BSU Alangilan Billiards coach wants to know whether players trained with the new practice drill have a higher. So, higher, that means one-sided siya. So, one-tailed. Our alternative hypothesis would be mu sub 1 is greater than mu sub 2. So, mas malaki yung mean nung new practice drill sa traditional drill. And our null hypothesis, as always, siya ay equal. So, first we will compute for S sub P. So, S sub P squared equals n sub 1 minus 1 times s sub 1 squared plus n sub 2 minus 1 times s sub 2 squared over n sub 1 plus n sub 2 minus 2. So, pag-plug in ng values, we will end up with 11 times 25 plus 9 times 36 over 20. So that is 275 plus 324 over 20, which is equal to 599 over 20, or 29.95 in decimal form. So we will find the square root of that since naka-square pa yung SP, and that is our SP. So that's 5.472. Next, compute for SE. SE equals S sub P times square root of the quantity 1 over n sub 1 plus 1 over n sub 2. So that's 5.472 times the square root of 1 over 12 plus 1 over 10. 5.472 times the square root of 0.1833 is equal to 2.343. Next slide, please. So we now have the SE, so we can now solve for the T. T is the difference between the mean of the first sample and the second sample minus D sub 0 over the standard error that we computed earlier. So that's 82 minus 78 minus 0 over 2.343. 4 over 2.343 is 1.707. So we have now the t value. So next step, so kailangan natin mahanap yung critical value para mag-come up tayo ng decision to reject or to accept the null hypothesis. So first, kailangan nating mahanap yung degree of freedom. So degree of freedom is previous slide. Degree of freedom is n sub 1 plus n sub 2 minus 2. So that's equal to 20. So our critical value after using the values of t and df is 1.725. So our t is less than the critical value. That means our decision is to not reject the null hypothesis. Therefore, our conclusion is there is no significant difference in mean scores between the two groups of BSU Alangilan billiards players at the 5% level of significance.
And for another example, in engineering data analysis, the instructor wants to find out if the group of students who reviewed with sample problems performed better on the quiz than those who only studied lectured notes. And we have two groups which consist of group A and B. For group A, the members are Hee-chan, Lance, and Ralph, who reviewed only using the sample problems. And for group B, Ken, Gian, Aldrin, and Earl, who only studied using lecture notes. So the given are, the n for group A is 3, and the mean is 87, and the S is 4. And meanwhile for group B, the N is 4, the X is 82, and the S is 5. And it is a one-tailed test. So for computing pooled variance, we're gonna use this formula, which is n sub 1 minus 1 times n sub 1 squared plus n sub 2 minus 1 times s sub 2 squared all over n sub 1 plus n sub 2 minus 2. And so substituting the values, it will be 3 minus 1 times 4 squared plus 4 minus 1 times 5 squared, and all over 3 plus 4 and minus 2. Simplifying that, we're going to get 32 plus 75 all over 5, which is 21.4. So to compute pooled standard deviation, we're just going to get its square root. So the square root of 21.4 is 4.63. So, and for computing the test statistics, we're just going to use this formula. T is equals to x sub 1 minus x sub 2 all over the square root of s sub b squared times 1 all over n sub 1 plus 1 all over n sub 2. So after substituting the values and simplifying it, we're going to get 5 all over the square root of 21.4 times 0.5833. And simplifying it further, we're going to get the test statistics of 1.42. And for finding its critical value, degrees of freedom is equals to n sub 1 plus n sub 2, which is n sub 2 minus 2, which is 5. And so the answer would be 2.015. So the decision would be, it is failed to reject the null hypothesis since the t is less than 2.015, which is the 1.42. And so the conclusion is at the 0.05 significance level, there is not enough evidence to conclude that the group who reviewed only using sample problems performed significantly better than the group who only studied lectured notes. Next slide will be. And for this sample problem, a bakery wants to check if two different ovens produce loaves with different consistency. Oven A had a standard deviation of 12G, close parenthesis, n is equals to 10. And oven B had 8G, close parenthesis, n is equals to 14. And if A is equals to 0.05, is the variability different between the ovens, and use the necessary testing method. So these are the table of our given, and for computing for F-test, the formula is F is equals to S sub 1 squared all over S sub 2 squared, which is 12 squared all over 8 squared, coming from this table. And simplifying it, we're going to get 2.25, and if A is equals to 0.05, which is two-sided, that would be the answer for our F-test. And for degree of freedom, we're going to compute it by using this formula. N sub 1 minus 1 is equals 9. And for degree DF2, we're going to compute it by using N sub 2 minus 1, which is 13. And for the next computation, F sub 0.025, 9, and 13, it is equals to 3.29, and F sub 0.975, 9, 13 is equals to 1. And we're going to divide it, and it will be 1 all over 3.29, which is 0.303. So the decision would be reject null hypothesis if F is less than 0.303, or if F is greater than 3.29 and 0.303, and less than 2.25, less than 3.29, then it is failed to reject the null hypothesis. And its conclusion would be there is no evidence that there exists different variances in loaf weights between oven.
In this problem, two technicians measured resistance using different methods. Technician A used ammeter voltmeter method, and technician B used multimeter method. Technician A standard deviation was 0.14 ohms with 8 samples, while technician B was 0.09 ohms with 11 samples. To check if one technician's measurements are more consistent, we use an F-test at 0.05 significance level. The computed F value was 2.42. The critical F values were 0.243 and 4112. Since 2.42 falls between these two limits, we fail to reject the null hypothesis, which means there is no significant difference in the variance of measurements between the two technicians. Both methods show similar consistency. Next page. This section In this section, two soil moisture sensors were tested for consistency. Sensor A has a standard deviation of 2.3% with 16 samples. Sensor B had 3.1% with 12 samples. The computed F value was 1 0.817. Since it falls between the critical values, we fail to reject the null hypothesis. The results shows no significant difference in variance between these two tensors. Next. In this section explains how to test two population proportion are equal. It uses two independent random samples with proportion p sub 1 and p sub 2. The null hypothesis states that the proportions are equal while the alternative suggestions they differ. The test static compares the difference between p sub 1 and p sub 2. When the null hypothesis is true, the pooled proportion is used to estimate the common value of p. Next one. Inference on two population proportions is used to test whether two population proportions are equal. We begin with the null hypothesis p sub 1 is equal to p sub 2. Two independent random samples are taken, each with its own sample proportion p sub 1 and p sub 2. The difference between these two proportions serves as the point estimator. For large samples, this difference is approximate normally distributed. The null hypothesis assumes that p sub 1 and p sub 2 are equal. We use full proportion p is equals to x sub 1 plus x sub 2 over n sub 1 plus n sub 2. The test statics is then compared as z is equal to p sub 1 minus p sub 2 over the square root of p quantity 1 minus p quantity times 1 over n sub 1 plus 1 over n sub 2. Next. In this problem, a survey was conducted to see if adults and teenagers differ in their preference for online shopping. Out of 400 adults, 210 said yes, while 160 out of 350 teens did. The sample proportion are 1 sub 1 are p sub 1 is equal to 0.525 and p sub 2 is equal to 0.4571, giving a difference of 0.06786. We tested the hypothesis at a significant level of 0.05. The pool proportion is p is equal to 0.4933 and the standard error is approximately 0.04. The test static is 1.8454 and the p-value for these two-tailed tests is 0.0637, which is greater than 0.05. Therefore, we fail to reject the null hypothesis, meaning there is not enough evidence to conclude that adults and teenagers differ in their preference for online shopping. Next.
And for another sample problem, two political candidates were compared in polls. Candidate A got 320 supporters out of 600 people, while candidate B got 275 supporters out of 580. Does one candidate have a higher or lower support than the other? Determine if so, given that A is equals to 0.01. And this is our given candidate A, and its sample size is 600 and its successes are 320. And for candidate B, the sample size is 580 and the successes are 275. So computing the pooled, it would be P is equals to 320 plus 275, which is the successes of candidate A and B, and it's their sum, which is 595. And for the denominator, it is the sample sizes of the two candidates, which are 600 and 580. So it would be 595 over 1180. And for zeta statistic, it would be 2.0332. And its two-sided p-value is equals to 0.04203. So the decision would be, since the p-value computed is greater than 0.01, then it is failed to reject null hypothesis. So the conclusion would be, there is no significant difference in the support received by the candidates.
So we got our problem here. Company wants to test if a new new design increase purchases. So we get our table design, old or new, sample size 250, 260, successes 95 and 130. So alpha is 0.05, one-sided upper. Then yung old natin, 95 over 250, which is 0.38. Then new design is 130 over 260 was 0.50. Then yung pooled proportion natin is ano lang, success plus yung pagpa-plus lang natin yung dalawang success. Then which is sagot natin is 225 over 510 or 0.441. Then sa Z statistic natin, lagi lang sa formula, our value will be 2.728. Then for p-value naman is 0.00318. So we reject the null hypothesis. So therefore, the new packaging significantly increases purchases rate.
And that would be all, and thank you.